Myself Sayed Jamal Ahmed, and I am from civil engineering second year, and I am also a topic clear cement. Let's start. Cement. I have discussed all the topics cement, lime, water, but I cement. Cement in a general sense are adhesive and cohesive material which are capable of bonding together particles of solid matter into a compact durable mass. Its primary function being to bind the fine sand and coarse aggregate particles together. Joseph Aspidin. Joseph Aspidin was the first to introduce Portland cement in 1824, formed by heating a mixture of limestone and finely divided clay in a furnace to a temperature. Cement is the two types: argillaceous and calcareous. Constituents of cement: lime 60 to 65%, silica 17 to 25%, alumina 3 to 8%, gypsum 3 to 4%, iron oxide 3 to 4%, magnesium 1 to 3%, sulfur 1 to 3%, alkalis 0.2 to 1%. Lime imparts strength and soundness. Excess it becomes difficult to combine with other compounds. Free lime will be present in clinkers, which makes cement unsound, causes it to expand and disintegrate. Deficiency reduces strength of cement, causes it to set quickly. Second, silica 17 to 25% impart strength to cement. Excess increase strength of cement, but increases setting time of cement. Third, alumina 3 to 8% impart quick setting property, reduces clinkering temperature. If it is in excess, weakness the cement. For gypsum 3 to 4% present in form of calcium sulfate used to increase initial setting time of cement. Iron oxide 3 to 4% imparts color, strength and hardness to cement. It introduces reddish brown tint to the cement. Magnesium 1 to 3% imparts strength and color to cement. Excess makes cement unsound. Sulfur 1 to 3%. It is also responsible for imparting soundness. Note: soundness due to lime and magnesium can be measured directly, but no test is available to measure soundness due to sulfur. Alkalis 0 to 1%. Presence of alkalis causes efflorescence and staining of structure. Alkalis react with water and white gray spots are formed. Alkalis accelerate setting of cement paste. Bogus compound: various constituents combine in burning and form cement clinker. The compounds formed in the burning process have properties of setting and hardening in presence of water. First, tricalcium aluminate is known as cellite. Second, tetracalcium aluminoferrate is known as phthalate. Third, tricalcium silicate is known as alite. Fourth, dicalcium silicate is known as belite. Tricalcium aluminate C3A 4 to 14% by weight, formed within 24 hours of addition of water in cement, responsible for maximum amount of heat of hydration. It is responsible for initial set, a higher heat of hydration and greater tendency to volume change. Tetracalcium aluminoferrite C4AF 10 to 8% by weight. It is also formed within 24 hours of addition of water to cement. Amount of heat of hydration involved during formation of this compound initially is comparatively more, which goes on decreasing with time. It is also responsible for flash set but generates less heat. uh, Tricalcium silicate C3S 45 to 85% by weight. It is supposed to be the best cementing material and is well burnt cement, formed within a week of addition of water in cement, responsible for development of early strength of cement in initial stage. Dicalcium silicate C2S 15 to 35% by weight. It is formed very slowly after addition of water in cement and may require a year or so for its formation. It imparts resistance to chemical chemical attack. It is responsible for a progressive strength of cement in later stages. No matter if early strength is required increase C3S emergency road work, prefabricated construction work, it is etc. Strength in required to be increases in later stage increase C2S. Hydration of cement. The chemical reaction between cement and water is known as hydration of cement. Heat of hydration of ordinary Portland cement during 7 days is about 89 to 19 calcium per gram, and during 28 days is about 90 to 100 calcium per gram. Water about 23% of by weight of cement is required to carry out the complete hydration. About 15% of water is used up in filling whites of the cement particles. Hence, effectively 38% of water by weight of cement is required to carry out complete hydration. Heat of hydration C3A, C3S, C4AF, C2S. Rate of hydration C4AF, C3S, C3S, C2S. Manufacturing of cement. Manufacturing of cement included three basic operations: first mixing, second burning, third grinding. Method. First dry method, second wet method. Dry method is new, wet process is old. Dry process, new method. Argillaceous crushing 25 then 5 grinding, fine grinding in tube mill, then storage and mixing of raw ingredients in correct proportion, then preheating at 800 degree Celsius by exhaust gases. Fed to rotary kiln for burning 14 to 1500 Celsius. Clinkers are formed. Fine grinding in tube mill. Cement salts particles and then cooled down and packed. Wet process is same as dry process. But one thing is different. 1500 Celsius to 1600 Celsius burning for kiln, and then same all things. Testing of cement. Testing of cement is carried out to analyze the presence of desirable properties in it. Testing of cement is two types: first field test and second laboratory test. Field test, color test, physical properties test, stain test. A laboratory test is one first fineness test, second standard consistency test, third setting time test, for soundness test, fifth stain test, chemical composition test. First field test. Field test. First color test. Cement should possess uniform gray color. Second physical property test should feel smooth when rubbed in between fingers. Cement should sink in water and should not float over the surface. Samples should be free from presence of any lumps which are formed due to absorption of moisture. Strain test. Prepare a block of cement to be tested of size 25 into 25 into 200 cubic mm. Immerse in water for 7 days. Now remove the mold and subject it to point load of 340 Newton by placing it over suppose a 150 apart. Samples should show no sign of failure under the application of this load. Lab test. First, fineness test is used to check proper grinding, which has direct impact on rate of hydration, rate of gain of strength, and evolution of heat. A sieve test: take 100 gram of cement and place it on IS sieve number 9. Performs saving for 15 minutes. Weight of a residue should not exceed 10% of original weight for OPC. The air permeability test represented in terms of specific surface area, centimeter square per gram. Balance air permeability apparatus is used based on relationship between flow of air through cement bed and surface area of cement particles forming the bed. For OPC, SSS should not be less than 2250 centimeter square per gram. For rapid hardening cement, SSS should not be less than 3250 centimeter square per gram. Ordinary Portland cement is 10.225. All the picture is shown. Second, standard consistency test. Standard consistency should be known before we know about soundness. Standard consistency permits a penetration of a Vicat plunger of size 10 mm die and 50 height up to depth of 33 33 to 35 mm from top into the mold. We find the water content at which the cement consistency is produced. Take 500 gram of cement and add 23% of water by weight of cement in first trial. Lower the plunger gently up to surface of mold and release quickly. The moisture content at which this cement paste of standard consistency is produced is termed as P. Third, setting time test carried out to know whether cement is deteriorated due to storage. Two times are associated with setting of cement. A. Initial setting time. B. Final setting time. Initial setting time. Time which is being measured from the instant water is added to cement up to the time cement start looking its plasticity. Take 500 gram cement and gauge it with 0 to 0.85 p. Lower the square needle gently and release it quickly. No time required by needle to penetrate 30 to 35 from top. This time is called initial setting time. For OPC, initial setting time is 30 minutes. Final setting time. Time which is being measured from the instant water is added to cement up to the cement completely loses its plasticity and attains sufficient firmness. Take 500 grams cement and gauge it with 0.85 m. Lower the annual collar with needle gently and release it quickly. Final setting time is the time when annular collar fails to make an impression over the mold, but needle does so. For OPC, final setting time is 10 hours. Soundness test. It is important that cement after setting does not show any appreciable change in volume as it seriously affects the durability of the structure. Soundness of cement is due to lime, magnesium, sulfur. The difference in reading in both the parts of test should not exceed 10 mm for OPC. With soundness due to lime and magnesium, this test is sensitive to both lime and magnesium. Prepare a mold of a lean cement of size 25 into 25 into 250 mm. Place in an autoclave in which steam pressure increases up to 21 kg per centimeter square and is maintained for the next 3 hours. The mold is removed. Percentage expansion of mold is noted in each direction, which should not exceed 0.8% for OPC. Strain test, compressive strain test, cement annual sand 1 to 3 ratio 3 specimen cubes are prepared and cement sand and water are taken as 135 gram and 55 gram. Mortar is filled in size of 70.5 mm mold and immersed in water for 7 days curing period. Compressive strength of cement is tested in universal testing machine. For OPC 33 grade strength at 28 days 33 in Newton mm square at 7 days 2 by 3 strength at 28 days at 3 days 50% strength at 28 days. Tensile strength test. Quicker indication of defect in cement is obtained than any other test. Cement sand is taken 1 ratio 3 by weight. Water to be used is calculated P by 5 plus 2.5 P percent of water required for standard consistency at 27 degrees Celsius. Ordinary pottery cement should have a tensile strength of not less than 2 Newton per mm square after 3 days, 2.5 in per mm square after 7 days. Dimension of standard brick weight. Tensile strength failing load by 25.4 into 25.4. Chemical composition. The ratio of alumina to iron oxide should not be less than 0.60. The ratio of lime to silica alumina and iron oxide should not be greater than 1.02 and should not be less than 0.60. This ratio is termed as lime saturation factor. Specific gravity test. It is done using Lee-Chartley flask. The flask is filled with either kerosene free of water or naphtha or to a point on the stem between 0 and 1 ml mark. 64 gram of cement is introduced in it and rise in volume is observed. Specific gravity of homogeneous cement particle. Cement is 3.15. Bulk density of cement is 40 kg per m cube. Total weight of magnesium should not be greater than 5%. Total loss on ignition when heated to 100,000 degrees Celsius should not be greater than 4%. Total sulfur content should not be greater than 2% 5%. Weight of insoluble residue should not be greater than 1.5%. Ordinary Portland cement. It is cementing material resembling a natural stone quarried from Portland in UK. It is classified as 33 grade IS 269 43 grade IS 8112 53 grade IS 12669. IS 10262 has classified OPC grade wise from A to F as per 28 days compressive strength. The picture is shown as rapid hardening cement. Higher rate of development of strength must not be confused with a quick setting time. The strength of RHS at the age of 3 days is same as that of OPC at 7 days. After 90 days, strength of RHS and OPC are almost same. Using prefabricated construction of our cold weather concreting extra rapid hardening cement. Produced with intergrinding rapid hardening cement clinkers with CaCl2 proportion of which should not be greater than 2% of weight of cement. This cement should be mixed, transported, compacted and finished within 20 minutes of its formation. Sulfur resistance test. OPC is a highly susceptible to attack of sulfate. It's manufactured by reducing proportion of C3A and C4F such that C3A is not greater than 5% and C2C3A plus C4F should not be greater than 25%. Super sulfate cement produced by intergrinding granulated blast furnace slag and 10 to 15% hard burned gypsum and 5% cement clinkers. Portland slag cement. Granulated blast furnace slag plus gypsum plus cement clinkers offer high resistance against attack of chlorides and sulfates. Quick setting time. Reduced by adding a small quantity of alumina sulfate. Fine grinding the cement clinkers are reducing proportion of gypsum. Low heat cement produced by reducing proportion of C3A about 5% and increasing the proportion of C2S about 46%. IRS T40 cement, a special type of cement used to manufacture sleepers for Indian Railways. Hydro cement is produced by intergrinding cement clinkers with water implanted film forming substance like oleic acid and acetic acid. Portland pozzolana cement. Pozzolana is essential is siliceous and aluminous compound which itself does not possess any presence of water. It reacts with COS to formed during hydration process to form a compound which possesses conducting property. It has low heat evolution and is used in the places of mass concrete such as dams and places of high temperature. Thank you.